Have you ever observed a mason building walls? And by the collection of walls building rooms, and by the collection of rooms building a huge building. Now can you think what is the building block of a huge building? Very simple answer is the building block of a huge building is a brick. A small brick forms the building block of a huge building. Now think about an ant hill. A small ant makes an ant hill. What is the building block from which this ant hill has been made? Think over it. A small grain of sand forms the ant hill. So similarly, the building block of all forms of matter is atom. The smallest particle is atom that forms the different forms of matter. It is so small in size that we can't even see it. It can only be seen by very highly advanced instruments like electron microscope. Now the size of the atom is measured as atomic radius, and the unit for measuring the atomic radius is nanometer. The short form is nm. 1 nanometer is equal to 10 raised to the power minus 9 meter, and 1 meter is equal to 10 raised to the power 9 nanometer. Now let us see the relative size of the various particles. The smallest particle, that is atom, hydrogen atom, its atomic radius in meter is 10 raised to the power minus 10. Water is a compound made up of water molecules. So the radius, the size of water molecule is 10 raised to the power minus 9 meter. The size of hemoglobin molecule, its radius, atomic radius is 10 raised to the power minus 8 meter. Now let us see the size of a grain of sand, which we can see is 10 raised to the power minus 4 meter. Ant is very small in size. What is its radius? 10 raised to the power minus 2. And a watermelon, which is very big, which you can see easily, what is its size in meters? 10 raised to the power minus 1. So this is just comparative study of the sizes. So we can compare a smallest particle atom with a quite big watermelon. So you can very well think how small is the size of an atom. Now you will think that why should we bother about atom which is so small in size, which we can't even see with the naked eyes. So it is very important to study about matter and its smallest particle, that is atom. What is atom? What is it made up of? What is its nature? So we will study in detail about atom. In the beginning, the names of the elements were derived from the place where they were found for the first time. For example, copper was first of all found in Cyprus, so its name was derived from Cyprus, and sometimes from the colors of the elements, like gold. Gold is yellow in color, and in English gold means yellow. So the name gold was derived because of its color. Now it is easy to write the symbols in place of the name. So symbols were derived, and nowadays IUPAC, International Union of Pure and Applied Chemistry, approves the symbols. Now symbols are generally the first letter of the name of the element, or the first two letters, or maybe not the first two letters, or first and the third letter also sometimes. So let us see, like hydrogen, the symbol is H, the first letter. Oxygen, symbol is O. Carbon, the first letter, the symbol is C. Now there are some elements which start with the same letter C, like calcium, chlorine, cobalt, copper. Now all these elements are starting with the same letter, so they cannot have the same symbol. So in this case, the first two letters were taken as the symbol. The first letter is written in the upper case, and the second is written in the lower case. In the case of chlorine also Cl. So first and the third letter form the symbol of chlorine. Here also the first letter is in the upper case, the second in the lower case. Never write C and L in capital. Cobalt, here first two letters CO, O is small letter. Copper. Now in this case the symbol is derived from its Latin name cuprum, so its symbol is Cu. So like this the symbols were derived, some from their names and some from their Latin names. So see these symbols of a few elements which are very widely used. Try to memorize them, but due to repeated practice and writing the formula again and again, you will gradually learn the symbols. So go through this a table and see some of the symbols you might be knowing, and some of the symbols you can learn by repeated practice. Some of the symbols are derived from the Latin names of the element. So let us see which are the elements in which Latin names are used to make the symbols, like sodium. The symbol of sodium is not SO but Na, and its Latin name is natrium. Potassium, symbol is K and Latin name is kalium. Iron, symbol is Fe, its Latin name is ferrum. Copper, its symbol is Cu and its Latin name is cuprum. Silver, its symbol is Ag and Latin name is argentum. Gold, symbol is Au and Latin name is aurum. Mercury, symbol is Hg and Latin name is hydrargyrum. Lead, symbol is Pb and its Latin name is plumbum. Tin, symbol is Sn and its Latin name is stannum. So, you can also gradually learn the Latin names of these elements from which the symbols have been derived. According to Dalton's atomic theory, each element had a characteristic atomic mass, that the atoms of the same element have the same mass and atoms of different elements have different mass. Now, Dalton's atomic theory could prove the law of constant proportion. This encouraged the scientists to find out the actual mass of an atom. Because the atom is very small in size, it is not at all easy task to find out the actual mass of an atom. Nowadays, of course, it has been found the actual mass of an atom is very, very small. As you know, hydrogen is the lightest element and the mass of hydrogen atom is 1.673 into 10 to the power minus 24 grams. Now, to do the calculations with such a small mass, it is not an easy task, it is very inconvenient. You can also see mass of carbon atom, which is heavier than hydrogen, that is also very, very small. So, the scientists, they thought about using the relative masses based on the laws of chemical combinations. Let us take an example of carbon monoxide. Now, it was found that 3 grams carbon react with 4 grams oxygen, right, or we can say carbon combines with 4/3 its mass of oxygen. Now, if we take the unit of atomic mass as 1 AMU, atomic mass unit, but nowadays instead of AMU, the unit of atomic mass is U, that is unified mass. It has been approved by IUPAC. So, instead of AMU, now we use the term U. So, we can on the basis of this we can say the mass of carbon is 1 AMU or 1 U and that of oxygen is 1.33 AMU or U, right. This is a fractional number and though it is very convenient as compared to such a small mass, but later on it was thought that oxygen can be taken as standard and 1 AMU or 1 U is taken equal to 1/16 of mass of oxygen atom. Now, later in the year 1961, carbon was taken as standard with atomic mass 12, because carbon has isotopes with the mass 12 and 14 also, but that isotope in which the mass of carbon is 12 is taken as standard reference. Carbon atom has 6 protons and 6 neutrons, so its mass is taken equal to 12 AMU or 12 U, and the atomic mass is then compared with the mass of carbon atom taken as standard. So, when we talk about atomic mass, we do not talk about the actual mass of the atom, we talk about the relative mass of an atom, of an element in comparison with the mass of carbon atom. So, what is atomic mass actually? When we talk about atomic mass, atomic mass is the relative mass of an atom, of an element, as compared to 1/12 of mass of C12 atom. So, 1 AMU or 1 u is equal to 1 upon 12 of mass of C12 atom. So, this is the mass in comparison. When we say the mass of oxygen is 16 AMU or 16 U, it means that oxygen atom is 16 times heavier than 1 over 12 of mass of C12 atom. Now, as later on it was calculated that actual mass of carbon atom in grams is 1.9926 into 10 to the power minus 23 grams. So, if we divide it by 12, we can get the value of 1 u equal to 1.6605 into 10 to the power minus 24 grams. So, now on the basis of this, from the atomic mass you can also calculate the actual mass of an atom, of an element, by multiplying with this value. But actually in practice we use atomic masses for the various calculations, but if you are curious to know the actual mass in grams, then you can always do the calculations. Now, here in this table are given names of certain elements and their atomic masses. There are so many elements, only some elements are written here. You can if you can learn some of the atomic masses, it is well and good. Otherwise, by practice you will come to learn about the atomic masses of the elements. Now you know that atoms are smallest particle of all forms of matter. They are very small in size and we cannot even see them. Now the question arises, how do atoms exist? We cannot see them, but they do exist. The atoms of inert gases like helium, neon, argon, krypton exist as atoms, single atom, and the aggregate of atoms then form the inert gases. Now, as you know, inert gases are inert in nature, chemically unreactive, and they are unreactive because the atoms of these inert gases have got stable electron arrangement. The atoms of most of the elements are very reactive, and atoms of the most of the elements occur either in the form of molecules or in the form of ions. Now, let us first of all know what is a molecule. A molecule is electrically neutral, it does not have any charge, and it is formed by the combination of two or more atoms of the same element or different elements. Now, if similar atoms chemically combine, it forms the molecules of element. If atoms of different elements chemically combine, it forms the molecules of a compound. Now, also you must know that when molecules or ions are formed, the atoms attain a stable electron arrangement, just like that of inert gases. So, that is why molecules or ions are formed. That is why most of the elements cannot exist as atoms, because in order to attain a stable electron arrangement, atoms of the same element or different elements chemically combine and form molecule. So, now let us see the molecules of elements. Now, some of the molecules contain 2 atoms, some contain 3 atoms, like for example oxygen. Oxygen does not exist as oxygen atom, it exists as O2 molecule. So, the number of atoms present in a molecule is called atomicity. So, let us now discuss what is atomicity and how the atomicity changes in different elements. As just now I have told you that inert gases exist as single atom, so they are monoatomic in nature. All the inert gases are monoatomic, like some examples are given here. Argon, helium are monoatomic and the symbols are also given. Oxygen, nitrogen, hydrogen, chlorine are diatomic. That is, there are two atoms in the molecule of these gases and they are written as O2, N2, H2, Cl2. Now in the molecule of ozone there are 3 atoms, so it is triatomic and its symbol is O3. In phosphorus there are 4 phosphorus atoms chemically combined together, it is tetraatomic and its symbol is P4. Sulfur is written as S8. What does it show? That there are 8 atoms in a sulfur molecule, its atomicity is 8. So either we can call it polyatomic or octaatomic. When atoms of different elements combine together chemically, a molecule of a compound is formed. Now these atoms of different elements, they are bound together by forces of attraction, strong forces of attraction, which are called bonds. So now let us see some of the examples of molecules of compound like water, carbon dioxide, ammonia, and see how the atoms of different elements are present in a molecule in a definite proportion, in a definite ratio by mass, and how to calculate this ratio by mass by knowing the atomic mass of the element. Now let us take an example of water. Water is a molecule, its formula is H2O. What are the elements present in water? So these are hydrogen and oxygen. So as you know, formula is H2O. Now how to find out the ratio by mass? By knowing the atomic mass of hydrogen and atomic mass of oxygen, we can find the ratio of hydrogen to oxygen present in water molecule. So hydrogen symbol let us write here, oxygen, which are present in a water molecule. What is the atomic mass of hydrogen? It is equal to 1. But how many atoms of hydrogen are present in water molecule? 2. So mass of 2 hydrogen atoms will be 2 AMU or 2 U. So let us write 2 here. What is the atomic mass of oxygen? It is 16. So we write here 16. So what is the ratio of hydrogen to oxygen? It is 1:8. So water molecule is always formed by the combination of hydrogen and oxygen in the ratio of 1:8 by mass. So the ratio of hydrogen to oxygen is 1:8. Now let us find out the ratio by mass in the case of ammonia molecule. Now think about the formula of ammonia. You all might be knowing it. It is NH3. So now write the name of the elements. It is nitrogen and hydrogen. Now we will find out the ratio of nitrogen is to hydrogen present in ammonia molecule. Nitrogen is to hydrogen. There is one nitrogen atom, its atomic mass is 14. And how many hydrogen atoms? 3. Mass of one hydrogen is 1 U or 1 AMU. So mass of 3 hydrogen atoms will be 3. So in the case of ammonia, the ratio of nitrogen to hydrogen is 14:3. Take the case of carbon dioxide. Let us find out the ratio of carbon to oxygen atoms present in a carbon dioxide molecule. You should know about the atomic mass of carbon and oxygen for this. So, atomic mass of carbon is 12 U and that of oxygen is 16 U. So, what is the ratio? But there are 2 oxygen atoms, so we cannot write 16 here. 16 has to be multiplied by 2, so it becomes 32, right. And now find out the simplest ratio. It is 3:8 by mass. So, write the names of the elements present in carbon dioxide molecule. It is carbon and oxygen, and the ratio of carbon to oxygen is 3:8 by mass. Also, from ratio by mass we can also find out the simplest ratio, which gives us the number of atoms present in one molecule. So, how many atoms are present in one molecule of a compound? How can we find out from the ratio of the mass, ratio by mass and by atomic mass? Let us see. Let us take the case of water again. The elements present are hydrogen and oxygen, and the ratio by mass we have already calculated. So, let us write it here. It is 1:8 by mass. Now, the atomic mass of hydrogen is 1 U and atomic mass of oxygen is 16 U. You already know it. And how to find out the simpler ratio? Mass ratio upon atomic mass is divided. So, 1 by the atomic mass of hydrogen, that is 1, it becomes equal to 1, and the here the mass ratio is divided by the atomic mass, that is 1/2, right. Now, how to find out the simpler ratio? We have got 1:1.5, 1/2, right. Simpler ratio is found by multiplying both by 2. So, what do you get? 2:1. So, in water molecule, hydrogen and oxygen are present in the ratio of 2:1. So, in water, hydrogen is to oxygen are present in the ratio of 2:1. So, formula of water is H2O. Same way you can find for ammonia. So, let us write the symbols of the elements present in a molecule of ammonia, and the ratio we have already found, that is 14:3, ratio by mass. Now, write the atomic mass of nitrogen and hydrogen. Atomic mass of nitrogen is 14 and that of hydrogen is 1 U, right. And now, mass ratio has to be divided by the atomic mass. Mass ratio is here 14 by 14, that is equal to 1, and here mass ratio is 3, 3 by 1 is equal to 3. So, the simpler ratio is 1:3. So, in ammonia the ratio of nitrogen is to hydrogen is equal to 1 is to 3. So, 1 nitrogen atom and 3 hydrogen atoms are present in 1 molecule of ammonia. You can do the practice by taking some more examples like carbon dioxide, etc.